Alright, in this video we're going to add another layer to what we started the other day. We looked at this equation, N2 plus H2 makes NH3, and we balanced it with our coefficients to determine our mole ratios. And our mole ratios are nothing more than conversion factors that allow us to change between the different moles to get from moles of one substance to moles of another substance using anything in this equation. So we're going to now take this information and we're going to add a little bit more information and interpret some more out of that. If you know the moles of one substance and you can find moles of something else, you could then take it and you could be asked to find the grams of that particular substance. And they could even further start you with grams of your original substance. So you can see that in addition to this one fraction problem, we could have some additional fractions that we would be doing. So let me change my sheets here. We're going to go back to the original equation. So N2 plus H2 makes my NH3, and I had it balanced with a 1, a 3, and a 2. And in this example, we're going to look at some basic grams to grams stoichiometry. And we're going to use our mole ratio that we just learned to solve that. For instance, if I gave you an example problem where I provided with you, I said that we have 25 grams of N2, and I wanted to know how many grams of H2 I would need to react with that in order to use it all up. To start this problem, we're going to take the number that they give us, the 25 grams of N2, and we are going to put it over 1 because that's what we do when we're starting with conversions. We are going to set up our fraction and decide where will our units go. Now we are looking to go from grams of N2 into grams of H2, which is a totally different substance. I will caution you, you need to use your units, and units are now like a quantity and a formula, because you're going to be working between two formulas. So you need two different distinct pieces of information when you use your units. So be careful. Like for instance, we have grams of N2. We have a quantity and we have a formula. In the next fraction, in order to cancel it, I am going to have to put the grams of N2 on the bottom. The only thing that I can do with my grams of N2 is change it to moles. I can go from grams to moles using the periodic table and the molar mass provided. N2, each N, there's 2 of them. We can look up the mass, it's 14. That would give me 28 grams for every 1 mole of N2. So I'm going to plug in my 28 grams right there. Okay, I solved this off to the side. I now know from my previous work with the mole ratio, I can say that there is 1 mole of N2 for every 3 moles of H2, which is good because my problem is asking me to go from N2 to H2. So moles of N2, we have to put it on the bottom to cancel. We will not automatically put a number in here. We're going to go moles of N2, and we're going to use our mole ratio provided in the balanced equation to fill in the numbers. Now, this case, I have 1 mole of N2 and I have 3 moles of H2. I am not finished yet. I was asked to find grams of H2. I have moles of H2, but that is a simple conversion using the molar mass. I am going to put my units of moles of H2 on the bottom, so it will cancel, and I can look up the molar mass of H2. Each H, there's 2 of them. They have a mass of 1. That gives me 2 grams of H2 for every 1 mole. And that would be my molar mass, and I'm going to plug it in to my problem. All right. Let's go back and check our units. We have grams of N2 on the top and grams of N2 on the bottom, so I'm canceling them. I have moles of N2 on the top and moles of N2 on the bottom, so they cancel. I have moles of H2 on the top and moles of H2 on the bottom, and they cancel. And I'm left with grams of H2, which is what I wanted to solve for. So in this problem, I'm going to take 25 divided by 28 times 3 divided by 2. So let me go ahead and calculate that. 25 divided by 28 times 3 times 2, and I get an answer of 5.36 grams of H2. Now, you need to be careful. You need to make sure you have both the gram and the formula, or the mole and the formula, and that everything is lined up. And we've canceled and we've gotten our answer. If we put in 25 grams of N2 into this balance equation, we would need 5.4 grams of H2 in order to make the reaction go. The only new piece of information that we've learned in this chapter is this mole ratio piece. The other information that we had from prior knowledge was molar mass of each substance. So this stoichiometry is nothing more than one big conversion process. You need to pay attention to the equation and the coefficients provided. You need to pay attention to your units to make sure that they cancel. And then the process is not as complex as it might appear. Okay, double check. Make sure your units line up. Make sure you have both the quantity and the formula. You've done your molar masses and you've done your math correct.